Hi, I'm James. So as you can see from the previous episode, I signed up for a private candidate to sit the O-level chemistry examinations, and I just sat for the chemistry paper 3. I apologize for uploading the video so late because I had a midterm to study the day after the exam, so it is only until now that I'm free to record the video. Without further ado, let me reflect on what happened during the exam. Before the exam, I was quarantined for 50 minutes in a waiting room with all the other students that took the exam. I talked to some of the students and I was actually pretty awkward and embarrassed because one of them actually thought that I was going to a JC. And in the waiting room, I obviously felt like I was an imposter because I was just one of the three private candidates in the room, and therefore it felt super awkward. And I could see that most of the students were trying to study last minute for the exam as they look through their very thick piles of notes regarding the chemistry practical. After 50 minutes, I finally entered the lab, and what I saw was all those equipment. Firstly would be the burette on the retort stand. I realized that it was such a bait, as I will see later, because it was not the kind of titration that I was expecting. Secondly would of course be the usual QA reagents. And thirdly would be the crucible with heating stand. And when I saw that it required heating, I was instantly a bit worried, especially for my safety, because I haven't operated a Bunsen burner for quite a long time. My instinct was that I must definitely use goggles before I perform any such heating, because I know that heating is actually a more dangerous activity. When the exam started, I flipped through the exam paper, and these were the questions I saw. So the first question was about thermometric titration, which was obviously not the standard kind of titration, which I think most secondary students are more familiar with, which is the one that just titrates from the burette, and then you take the start point and end point, and then you calculate the concentration of the acid and base. For this is thermometric titration. So different combinations and different volumes of sulfuric acid and sodium hydroxide are reacted together. And from this, there's heat evolved and the temperature change is recorded. After that, a graph is plotted to determine the point in which all the base neutralize all the acid completely. So that is the point whereby a given volume of acid will neutralize a given volume of base totally without any limiting reagent or excess reagent remaining. From this, the concentration of sulfuric acid is determined given a known concentration of NaOH. So this was another form of titration, but I think it's a form of titration which many students may not have prepared for. But in reality, I feel that it is just another variation in which to determine the concentration of the acid and base, but really the stoichiometric concepts are really very similar. Secondly, I saw the second question. Uh, the first part was about heating to decompose. I think this question was pretty direct. It was just about heating a metal salt to decomposition and then measuring the loss in mass. Next would be to determine the percentage of metal in the salt based on the percentage of mass loss. I found that this question was pretty direct, just that it was a bit more dangerous on the safety side because it required intense heating. Question 2b would be about qualitative analysis, which I found the weightage to be 9 marks, which was pretty close to the 10 marks which I predicted in the previous video. The QA was to determine the identity of the metal salt that was used in the previous question and the identity of an unknown reagent. So there are two things, the salt and the unknown reagents. So that means that I will have to identify four ions, two cations and two anions. The first reaction would be to add the reagent to the metal salt and test the gas evolve. And the subsequent reactions are to perform anion and cation tests on the reagent and the mixture after the reaction. So I find that the last two parts are pretty standard because the anion and cation tests are pretty straightforward and they are given in the QA notes behind, so I don't think it may be too difficult. Next will be the planning, will be 7 marks. This planning was slightly different from previous years, and I think this planning involves the mole concept heavily. This is to determine if the reaction between iron and copper 2 sulfate produces iron 2 or iron 3 ions. The reaction produces solid copper, so this is a redox reaction. In this planning question, I'm given 1 gram of iron powder to start with and copper 2 sulfate solution. Now, I will share with you how I approach this practical examination. I started with question 2 first due to the recommendation on the board. In the lab, I was seated on the right bench and therefore I was recommended to start question 2 first. As I said before, I found that question 2A was pretty direct. It was just about measuring the mass of crucible and the crucible with a metal sword. I heated the crucible gently and then strongly. I wore goggles and made sure that all the objects were very far from the Bunsen burner. This was to avoid any incidents of my belongings or the question paper being burned, which I think would cause me to panic in the exam because is unnecessary trouble in an exam that could be stressful for most people, especially those that are actually taking the O levels for admission to polytechnic or JC. Next, I weigh the crucible and the decomposed salt after, and then I perform a few more concept calculations, which I found that were pretty straightforward. When I was heating and cooling the crucible, I started on question 2B to save time. For question 2B, I mixed the metal salt and the reagent together and I saw vigorous bubbling. And I already heavily suspected that it was carbon dioxide because the salt felt like a carbonate from the previous question already. Since I had a very strong inkling that it was carbon dioxide, I just used a tip pipette to bubble into the lime water and I saw white PPT produced. There wasn't too much white PPT, but I think it was significant enough for me to conclude. But I was still not very convinced. And then I saw that in the mixture of the metal salt and the reagent, there was still quite a lot of unreacted salt. So I just shook the test tube and collected the gas to test for CO2 again. And this time I saw a lot of white PPT. So I was very convinced. I actually also tried other tests such as by using the pH strips, which is the litmus paper, red and blue litmus paper. I tried to use that, but I don't think that it was very conclusive. And then since I had a very conclusive evidence that it was CO2 already, so I just moved on to the next part. For the cation test, I added NaOH and ammonia drop-wise separately. I added 1 drop and I saw white PPT for both. And then to test if the PPT would dissolve in excess base, I actually added a lot of base and then I shook very hard and then the PPT dissolved. So I could conclude that it was zinc ion because for both NaOH and ammonia, the same thing happened. White PPT produced and then it dissolves with the addition of excess base. For the ion identity, I was initially pretty confused because one of the ions was stated not to be in the QA table. I was pretty confused because when I did the reaction, I know that there was zinc and there was a carbonate and then there was chloride. But then these were the only ions that I was actually sure of. But when did a fourth ion appear? After I started doing question 2A again, then I realized that it may be H plus since it was an acid-base reaction. For question 3, the planning was significantly different from previous years, but obviously tested the mole concept because the first part was already involving the balancing of a chemical equation. As I took a few minutes to think, I was thinking of using excess copper 2 sulfate to react with the iron powder and then measuring the mass of the copper evolved after filtering and drying. After that, I will compare the moles of iron compared to the moles of copper produced. From this, I could identify whether if it's iron 2 or iron 3 produced based on the chemical equation that was given in the first part that they asked to balance. So that was already a very big hint. Last but not least, I went to question 1. I found that it was pretty direct for the initial parts, but it was pretty tedious testing the various combinations of acid and base because there were 7 different combinations. After that, I drew the two intersecting line of best fit to find the volume of base that will react exactly with the acid. Afterwards, I found the more concept questions pretty straightforward after that to determine the concentration of the acid. To be honest, for this experiment, I found that the volumes reacted were not very exact, as the base was measured during a measuring cylinder and the acid was actually measured using a burette. So I found that using a burette was pretty unnecessary, and therefore the presence of a burette might have baited people initially to think that it was a normal titration when it was actually a thermometric titration, which involved measuring the temperature change instead. Since I did pretty fast, I finished with about 20 minutes left for me to check, which went according to my plan because I was allocating about 15 minutes to check the entire script in the end. In conclusion, about this chemistry paper 3, firstly, I felt that I saved a lot of time on QA gas testing as I managed to do it on the first try based on the clues that were pretty apparent. For the first part about the heating of a metal salt and the second part about the vigorous effervescence. So I felt that that was a pretty dead giveaway that it was very likely to be carbon dioxide. Secondly, I was pretty happy that I managed to stay calm even though I couldn't guess the cation not on the list initially, but I managed to calm myself down easily by doing other questions first and securing the marks on the other questions. I also found that I managed time well. Throughout the whole practical, I basically did fast enough such that I was on time with what I planned. For a 15 minutes question, I only plan to use about 36 minutes. I find that through this practical, one can learn that not all experiments will be familiar, such as a thermometric titration or even the planning questions, but basic concepts like mole concept and stoichiometry are very important and can take one very far because I find that most questions in the practical are just a variation of such concepts actually. So it is very important to study the base concepts well so that no matter what variation SEAB comes out with, you can definitely do the question because you know the basic concepts very well. So that is the end of my sharing. Thank you very much for watching.